You ever hit that point in your piano practice where it's like hitting a wall? You practice and practice, but you just don't seem to be getting any better.
Yeah, that's the ceiling effect.
Yeah,
And it
exactly.
can be so frustrating.
It really is. So we found this study.
That's a good one.
It's called Surmounting the Ceiling Effect of Motor Expertise by Novel Sensory Experience with a Hand Exoskeleton.
Kitschy. Right.
It is. It is. Published in Science Robotics just this month, January 2025. So it's cutting edge.
Very much so. And it looks at this problem in a fascinating way.
I know. It's like straight out of sci-fi.
A little bit, yeah. They're using robots to try to enhance human performance.
They used a hand exoskeleton robot. So tell me more about this study. How did they actually set it up?
So they had 118 expert pianists.
Wow.
Yeah, a pretty big study.
It's a lot of pianists.
Yeah, all very skilled. And they used this custom-built exoskeleton that could move the pianist's fingers independently.
So they like strapped them into this thing.
Yeah, basically. And the exoskeleton could move their fingers with incredible speed and precision.
Okay, and so what were they hoping to learn from this?
The big question was whether experiencing these movements passively, so the pianist isn't actually controlling the movement,
Right.
would that be enough to actually improve their playing?
So the thinking is just by feeling these like superhuman movements.
Yeah, the brain might pick up on some new patterns or
Uh.
techniques.
So did it work?
That's the crazy part. It actually did. They found that experiencing those fast, complex movements through the exoskeleton actually made the pianists play faster themselves.
No way. Just by feeling it. That's so counterintuitive. Yeah. What about all that stuff we hear about muscle memory and hours of practice?
That's what makes this research so interesting. It suggests there's more to skill development than just repetition and muscle memory.
Yeah.
It seems like the training actually changed the way their brains were planning and executing movements.
Okay, my mind is officially blown. So they basically rewired their brains through feeling, not doing. How did they actually measure that? They didn't like open up their brains, did they?
No brain surgery required. They used a technique called transcranial magnetic stimulation, or TMS.
TMS, all right. What is that exactly?
It's pretty wild. Imagine you could target a tiny area in the brain with a magnetic pulse,
Okay.
and then see how that affects muscle activity
So it's like zapping the brain and seeing what happens.
in a very controlled and safe way.
Okay, so they zapped the pianist's brain.
Before and after the training, yeah.
Oh, what did that tell them?
They found that the training with the exoskeleton actually changed the patterns of muscle activity triggered by the TMS. Meaning the brain was learning, adapting to those new movements, becoming more efficient at controlling the fingers.
So it's not just that they were playing faster, but their brains were actually becoming more skilled at those movements.
Precise.
That's incredible.
Mm-hmm.
But there's one thing I don't get. You mentioned that the training on one hand actually made their other hand better,
Yeah, it's wild.
even though it never touched the exoskeleton. How is that even possible?
That's the mystery of the intermanual transfer effect. Somehow, training on one side of the body can benefit the other side, even without direct practice.
Wow, it's like some kind of secret communication going on between the two halves of the brain.
Exactly. It's like they're sharing information, learning from each other behind the scenes.
So much we still don't know about how the brain learns. But we need to unpack these key findings a bit more. What exactly did they learn about the types of movement that lead to this improvement?
Yeah, that's where it gets even more fascinating. Remember, these were already expert pianists. They had to push them beyond their comfort zone.
Okay, so tell me, what kind of movements did they use?
Well, they tested out two different types, simple and complex.
Okay, I'm intrigued. Let's dive into that next.
So we've got these expert pianists, right? They're already really good.
Right, they've hit that ceiling.
Exactly. So just having them practice more of the same stuff,
Yeah, it's not going to do much.
it's not going to cut it. They needed something totally new, a movement that their brains and their bodies hadn't encountered before.
Okay, so they had to shake things up a bit.
Exactly.
How'd they do that with the exoskeleton?
Well, they used it to introduce movements that were physically impossible for the pianist to do on their own.
Okay.
And they actually tested two different types of movements,
Okay.
simple and complex.
All right, break that down for me. What's the difference between a simple movement and a complex movement?
So imagine all your fingers moving together at the same time.
Okay, like you're grasping something.
Exactly. That's a
Okay.
simple movement. Now, picture the kind of finger work you'd see in a really fast, challenging piece of piano music.
Okay, lots of independent finger movements.
Yeah, that's a complex movement.
Got it. So With the exoskeleton, they were basically trying to simulate like the finger movements of a virtuoso.
Yeah, and at a speed that no human could ever match.
Wow, okay. How fast are we talking?
They cranked the exoskeleton up to a speed of 4 hertz.
4 hertz.
That means 4 complete cycles of flexing and extending per second.
Whoa, that's crazy fast.
Way faster than even the quickest piano piece.
Yeah, I can't even imagine moving my fingers that fast. So did both types of movement lead to improvements in the pianist's playing?
Here's the kicker. Only the fast, complex movements made a difference.
Really?
Yeah, just moving their fingers quickly in a simple grasping motion didn't do anything.
Huh. Interesting.
And get this, performing the complex movements slowly was also ineffective.
So it had to be that combination of the superhuman speed and the complex finger coordination.
It seems like
It's like the brain needed that wow factor to actually pay attention and learn something new, right?
Yeah, like it was saying, whoa, this is totally new. Maybe I can add this to my toolkit of movements.
That's incredible. It's like you can reprogram your brain to reach new levels of skill by just exposing it to these mind-blowing experiences.
Yeah.
But what about the physical side of things? Didn't the exoskeleton like make their muscles stronger or more coordinated?
That's the other fascinating finding. Even though the exoskeleton was moving their fingers, the researchers made absolutely sure that the pianists didn't lift a muscle during the training.
Really?
Yep. They monitored their muscle activity the whole time.
Wow. So they were truly just passengers passively experiencing these movements.
Exactly. It really highlights that the learning was happening in the brain,
Fascinating.
not in their muscles.
Yeah. Okay. But how did they actually measure those changes in brain activity? You mentioned earlier using TMS, right?
Exactly. TMS was a key part of understanding how the brain was adapting to these new sensations. Remember, it's like being able to pinpoint a specific area of the brain.
Right, and giving it a little zap.
Right, and seeing how the muscles respond.
Okay, so they zapped the area of the brain that controls hand movements
Before and after.
before and after the exoskeleton training to see how the brain's response had changed.
That's it. And what they saw was pretty remarkable. After the training, the muscle activity triggered by the TMS became much more refined and efficient.
So it's not just that the pianists were playing faster, more accurately, but
Their brains were actually becoming more efficient at controlling those movements.
it's like you said, they got a software upgrade for their finger dexterity.
Right.
But I'm still stuck on this. How could training one hand make their other hand better? The one that never even touched the exoskeleton. It's like some kind of Jedi mind trick.
It really is mind-boggling. It's called the intermanual transfer effect. And while it's been seen in other studies, we still don't fully understand how it works.
Yeah.
One theory is that the two halves of the brain are always communicating and sharing information,
Okay.
even when only one hand is actually doing something.
So it's like the two sides of the brain are constantly learning and adapting from each other's experiences.
Working together behind the scenes.
This research opens up so many questions about the hidden connections and learning pathways in our brains. And this is seriously groundbreaking stuff, right?
Right.
Makes you wonder if we're like on the verge of a whole new era of skill development.
Oh, absolutely. It really does open up some exciting possibilities.
Like imagine being able to fast track your learning,
Yeah.
and breaking through those limitations that have been holding you back for so long.
It's a game changer for sure. But it also raises some big questions
Yeah, like what?
about the future of expertise. If we can use technology to boost our abilities like this,
Right.
what does it even mean to be truly skilled anymore?
It really makes you think, doesn't it? Like, does it cheapen the hard work and dedication that people put in?
Yeah.
Or is it just a new path to achieving mastery? I don't know. What do you think?
Tough question. I think it's probably a bit of both.
Yeah.
It's a tool like any other. It depends how it's used.
And who has access to it, right?
Exactly. And that's another big concern. If this technology becomes widely available,
Could it create a divide between those who can afford it?
and those who can't.
Yeah.
That's a good point. Hadn't really thought about that. It's like we need to be mindful of the potential downsides as well.
Definitely. We need to be thoughtful about how we use these technologies
Yeah.
as they emerge.
They have incredible potential,
Yeah, huge potential.
but we have to make sure they're used responsibly
Absolutely.
and for the benefit of everyone.
Couldn't agree more.
Well, on that note, I think it's time to wrap up this deep dive. We've covered so much ground today.
We really have.
From that frustrating ceiling effect to the potential of this mind-blowing hand exoskeleton.
And all the questions it raises about the future of skill and expertise.
Exactly. It's definitely given us a lot to think about. But before we go, I want to leave you with one final thought.
Okay.
If you could use this technology
Yeah.
to experience movements beyond your current capabilities,
Mm.
what skill would you choose to enhance?
Ooh, that's a good one. And what would you hope to achieve? It's something to ponder as we step into this exciting new frontier of human potential. Thanks for joining us on the deep dive.
It's been a pleasure exploring this fascinating research with you. Until next time.